In this video, we will learn how does Java support the conversion between primitive data types. Remember, Java is a strongly typed language. What that means is that it checks the data and makes sure that its type matches the type of the variable you are trying to assign it to. This is done as you compile. So if they turn out to be incompatible, there is a possibility that you will get a compile time error. Let's take an example to understand how this works. Assume you declare an int variable x, then you initialize the double variable y. Then you try to store y, which is a double, into the x, which is an int that doesn't accept fractions. This is a compile time error. If you try to do the opposite, however, by storing an int variable in a double variable, Java won't complain. So what are the rules? To understand the rules and the relation between the primitive data types in Java, let's have a look at them again. First, let's remove Boolean and char and focus on the numerical data types. Each data type occupies a certain number of bytes in the memory. Thus, it has a different range of numbers it can represent, with the byte being the smallest and double being the largest. Notice that we say double is the largest even though it takes 8 bytes just like the long, but its range is more significant. So the order we see here is a good ranking representation of the data types, with the most powerful being the double at the top. If you try to store a low-ranking data type in a higher-ranking data type, Java will not complain, and what it will do is automatically upgrade the low-ranking data type to the high-ranking data type. So this is called the widening conversion because you try to put a small data type in a bigger data type. For example, if we have a double x and int y, storing y in x is okay. Java will automatically upgrade the y temporarily to get 10.0 and be stored in x. Notice that y remains an int. The opposite direction, on the other hand, is called narrowing conversion, and Java doesn't allow it. This makes sense. You can't put a large data type in a narrow data type. Back to our earlier example, a double with a value of 2.5 can't be stored in an int x. So does that mean there is no way to store a double in an int? In fact, there is. This can be done using what is called the casting process. Casting is the process of manually converting a value from one data type to another, even if this means narrowing conversion will happen. So, widening casting is done automatically by Java, which we refer to as the widening conversion. What about narrowing conversion? In this case, you have to do that manually. You have to tell Java, I know what I'm doing, and I would like you to override the rules and store a large data type value in a smaller data type variable. So how do you do that? Here is an example. In general, casting is done by placing the destination data type in parentheses next to the data you want to store. So in this example, y is a double with the decimal point. I want to force store this in x, which is an int. So I say x is equal to int between parentheses followed by y. This way, Java performs the right-hand side of the assignment statement first by temporarily converting y to an int and then store it in x, which is also an int. This part that performs this casting is called the cast operator. Now, what do you think will be stored in x? It's going to be 2, not 2.5. So casting the double value in an int variable will lose data. That's why Java makes you do this manually, because it wants to make sure that you know what you're doing. Casting can be useful, but if done wrong, it can cause problems. Similarly, you can do casting with any other data type. So why do we cast anyway? In some situations, you will find that you need to use the nice properties of the destination data type. For example, assume that you are writing a program that you will put on a robot that you plan to send to Mars. You have limited memory resources on that small device and you need to utilize it efficiently. So if you know for sure that certain integer data values will never exceed the positive 127, for example, it would make sense to force that integer to be stored in a byte. This way, you save memory while you make sure that no problem will occur. So let's have a closer look at these rules. In general, if you have a mathematical expression that has a double with any other data type, the other data type will be upgraded to the double, and then the operation will execute and result in a double. Similarly, if you have a mathematical expression that involves a float with any other data type, except double of course, the other data type will be upgraded to be float. The operation will execute and the result will be float. And so on. The same thing will work for long. Then what about int? Int is the same, but is more interesting way. Let's see how. So in Java, byte and short variables can perform arithmetic expressions. So how that works? What Java does is that it converts them temporarily to int values and then perform the operation leading to an int result. So by default, everything below int gets upgraded to int, even if no explicit int variable present in the mathematical expression. Let's take an example to understand this. Assume that you declare a as a short. You also initialize two short variables, b and c, to be 3 and 7 respectively. If you add b and c, you get 10, which is a number that a short variable such as a should be able to store. The problem is Java will give you a compile time error. Why? Because b plus c is actually an int. Both b and c got upgraded to int and then added together, leading to an int 10. Now you are trying to store the int 10 in the short variable a, which Java is not going to allow because this is considered narrowing conversion. So how do we solve this? Casting. We cast the operation b plus c to be short and then store it in a, which is also short. Notice here that the casting will be applied to the whole mathematical operation of b plus c. This is the demo for the primitive data type conversion, and it's partially what we had in the primitive data type. The first thing you can see here is that you can assign an integer to a double. We have 10, which is an integer, an int literal, can be assigned to y, which is a double variable. So if I do something like this and I try to print y, it's going to print 10.0. So what happened here is that the 10, which is an integer, got upgraded to a double, which makes it 10.0, and then this was assigned to y, the double variable. Now, what if you try to do, so here that upgrade that happened automatically is actually widening conversion, which is allowed. Why? Because double is more powerful, it's higher rank than int, and that's why that upgrade was done by Java automatically. Now, what happens if you try to do the opposite? What happens if you try to put a double literal inside X? All right. Now, naturally, Java wouldn't allow this. This is a narrowing conversion, and Java doesn't let it happen. So here it will say incompatible types, possible lossy conversion from double to int. So you are trying to put a double, which is higher rank, it has more information, in int, which is lower rank, and in that case, it's not going to work. Even if you, by the way, even if you make it 4.0, which it doesn't have more information than just a 4, Java is still not going to do it. It's not going to take that. All right. So that's narrowing conversion is not allowed. So what you can do is to cast it. You try to tell Java, I know what I'm doing. I would like you to put the 4.9 in a cast of an int and then assign this to X. All right. So here you do this manually and tell Java, I know what I'm doing. Just do that, which is casting this into an int by using the int between parentheses. And then if you compile, now it works. All right. And what will happen is that this 4.9 is going to be suppressed to B4. All right. So whatever value you have here, less than 5, greater than 5, it's not rounding. Be very careful here. It doesn't round, it suppresses. So it cuts anything at the decimal point and after it. And that's what happens here. All right, the next demo is going to be for the shortened byte having no operations in Java. All right, so minutes here is 120. It's a short variable, and that's fine. 120 is within the range of short. It works. Now here, what happens is that we try to add 120 plus 120, which should give you 240. All right, let me comment this one for now. So it gives you 240, which is within the range of short again. But if you compile Java complaint, Why? It says that incompatible types, possible lossy conversion from int to short. Notice here that this equation, this whole demo here, this part doesn't have any integers, right? So in this case, what really happened is that this int, this short variable, when you try to add expressions, you cannot add short plus short. You cannot add short plus byte, byte plus byte. None of these are going to work, right? Because what happens is that minutes temporarily in this single line gets upgraded to int, then added to another int, giving you a total of an int, which is 240 as an int literal or value. Then that int you're trying now to narrow convert it into a short, which Java is not going to allow. So this is here, what is happening here is narrow conversion, and Java is not going to let it happen. So again, what you could do is to basically cast this by saying short. Notice here that since it's an expression, you have to enclose the whole expression into in a parentheses. All right, so this way now it works. Now Java compiles it, it's going to run normally without any problem. All right, now this is an int because notice here that if you have minutes, add to it 1, this gives you an int. I try to store it in an int, it's going to work without any problem. All right. The other thing that we want to talk about is the wraparound, which could happen due to casting, right? So what that means is that you have a byte which could take up to 127. So if you try to assign 127 to a byte, it's not going to complain. No problem here. It works. Try 128, it complains. Why? Because byte can actually take up to 127. So that once you got to 128, which is beyond the byte limit, it becomes an int literal. And in that case, it gets upgraded. And in that case, you cannot down or narrow convert it in. Again, you can cast it by telling Java, I would like to cast this as a byte. All right, which Java is going to listen to you and do it. Now, it's your responsibility, since you took that action of casting something X, is that you make sure that it doesn't mess up your code, right? So here what happened is that 128 is beyond 127, which takes 1. So where that is going to go, Java is actually going back all the way to the beginning of the byte representation, which is the negative 128. So if you are considering, like, if you think I'm adding 128 to my equation, you will end up subtracting 128. That's why the narrow conversion is not allowed by nature or naturally in instead you have to do it manually by casting using the cast operator.